This is the civil engineering design Calstock retaining wall proposition by Group 2.
Uh, this is the side plans. Retaining walls are built in these places with different heights on both sides. For example, in these pictures, they are built between the area close to the river and the residential area. Due to the different soil heights on both sides, a retaining wall is required to prevent the sand from flowing back and separate these two sides, a place near the river and the other place near the house.
Okay, I would like to talk about the cross-section of the wall showing the failure. Like if the web holes are blocked, hydrostatic pressure builds up behind the retaining wall. Like saturated soil is sustainably heavier than the dry soil, so the retaining wall may not designed to handle such a load. And then we can have a look at the crack that could happen in the concrete. The cracks could happen after the rain because the water immersed inside, which leads to the cracks of the concrete. Also, the broken precast could be the reason when the water is permitted inside. And if you look at the right marks, you can see that if there is loose of soil, expected passive pressure will not be mobilized, and as a result, the retaining wall could slide. That is also a failure.
In terms of the cross-section engineering drawing, we considered to utilize a cantilever design as opposed to the original gravity wall design, as we believe that it's going to add to its duration of the lifetime of the retaining wall. In order for us to choose the respective dimensions selected for the new retaining wall, we considered failure caused by overturning as well as failure caused by sliding. When making calculations with our dimensions, we considered the restoring moments as well as the moments caused by hydrostatic pressure as well as pressure caused by the backfill. And when considering sliding, we considered the frictional forces caused by the soil that are going to prevent the retaining wall from collapsing in comparison to the horizontal forces caused by the backfill as well as the surfaced road. Running through our checks, we got a factor of safety of 7.13 when considering overturning moments, and a factor of safety of 3.58 when considering sliding.
An excavator will be transported via the river to the site, as transportation via the road would be unsafe as the road is unstable and not wide enough. The 30-ton excavator will be used to remove the granite debris from the site. Then it will insert the temporary steel pilings. These steel pilings will be 1 meter above the ground and ensure the safety of workers when excavating, as it will prevent soil from sliding into the cavity. The base soil will be compacted with a plate compactor to ensure that it is flat and level. The steel mould for the base will be constructed by workers on site. Rebar will be inserted to ensure structural integrity and the binding between both parts of the concrete wall. Concrete is poured from a truck transported by the river and vibrated so it reaches all parts of the mould. Once cured, the steel mould will be removed.
A crane truck is being used to place the wall mold, followed by concrete being poured into the mold. When the concrete is set, the mold can be removed, and a worker will stand on a cherry picker to hold a wall stem against the wall to provide aesthetics. Weep holes and drainage will be installed to allow water behind the wall to escape. Now the cavity can be filled with the material excavated as well as from the old wall, and a road roller will be used to resurface the road. After machineries and fences are removed, the construction of the retaining wall is completed.
In the case of the construction of a retaining wall in Calstock, the first possible risk occurs when the concrete mixer and other types of trucks are loaded or unloaded from the boats that are in charge of transporting them across the river. Therefore, those trucks can tip in the river due to the lack of stability underground. To avoid this problem, fences were built near the river so that if trucks slide by accident, they won't fall in the river. Similar accidents can happen when transporting excavators across the river. The excavator could fall into the water, putting consequently the lives of workers at risk. Members of the public may decide not to comply with the rules and therefore access the site without authorization. As the site and its surroundings are not safe, those individuals might get hurt by falling from the height of the retaining wall. Similarly, workers can also fall and get hurt or even get trapped on site due to lack of visibility at night. A solid concrete balustrade that is more visible at night was built to prevent both visitors and workers from falling. There is also a risk of objects falling on site due to the instability of the soil, which might cause severe head injuries to site workers. Safety helmets should be worn by all individuals,